Welcome, everyone. This is the Working Group Device Management meeting from June 24th. We have a few items on the agenda. Before we start, I also want to give new people a chance to introduce themselves. I don't think we do, maybe we might. Anyone who wants to speak up now and just give a short introduction of themselves is welcome. Just raise your hand and it's your turn. Okay, then I'll do the usual status update first. We had cap freeze last week. We did not quite manage all of our enhancements that we might have done in this cycle. Let me get the project board on the screen and start the sharing. I didn't actually do that. I meant to, but didn't. So share screen. Yeah, here it should be. So this is the enhancement tab in our project board. We did manage to get a few beta updates merged. I think this is prioritized list. I keep forgetting. This one is we have two betas. The next time if you do a cap update, please include the cap title in the subject of a PR. Our PR template doesn't ask for it, but I think it's just a lot more readable. The cap number itself, we have too many caps. I don't always remember the number. So this is something that NVIDIA was interested in, the pod resource API and including information about DRA. The other one below it is the prioritized list. I remember that. This one is admin access. So I think that remains in beta. Or does it graduate? Well, we'll see. Anyway, we got some updates there. The important new ones, consumable capacity got merged. Don't remember what this one is. Health status, pod status. That's basically the legacy API for exposing device health in the pod status that plans to support DRA this cycle. Structural parameters, the big one, that is planned to go GA. Device binding conditions is new. It will be alpha if we make it. Yeah, we did another update of a core structured parameters cap to define the PCI root as a standard device attribute. Extended resources, that's another big one. That's about supporting the traditional pod resource API and map that to DRA devices on the fly, no user visible changes. Mix-ins, that's a resource slice update thing that will also is planned and has been planned for a longer while now. And that one is another beta graduation. Admin access. Yeah, I think there were two PRs for that. So yeah, I think that's what we are planning to do. What we didn't quite get reviewed and agreed upon in time is reserved for workloads. That's a conceptual problematic and difficult change. We just didn't get all details worked out. Implicit tolerations, I think that was just too new and didn't get enough reviews. Constraints with cell, there were some concerns from David Eads in particular as a PR production readiness reviewer about the scalability and complexity implications if we if we don't stop at the first solution but keep iterating until we find some combination of devices that satisfies all constraints. of a cell constraints for all devices defined in a cell expression, then we potentially keep iterating for a lot longer than before. And that needs to be explained a little bit more in the CAP to outline why, for the number of devices that this feature will be used for, it's not a problem or not expected to be a problem. Yeah, so I've talked a lot about CAPs because that's pretty much what we've been doing so far. Cap freeze was last Friday. Now people are still out, so don't expect too much activity on implementation PRs. Not yet, at least. But we now have roughly a month, I think, until code freeze. The good news is for most of the new things, we have pending PRs, prototypes at least, so we should be able to get the implementation ready. Reviewers will be a bottleneck again, I'm pretty sure, and that includes myself. Okay, that was it for status updates. Any questions? No, then Ale, yeah?
Yeah, I have a question. Sorry, I didn't have my hand raised, but I don't
No,
have other, so I'll go. Um, in the DRA board, there was a cap about um, the extended resources are transparently getting
yeah.
access to DRA now. I wanted to ask with that cap, I'm sorry, I didn't get a chance to look at that cap, but with that cap, does quota evaluations of DRA devices change in any form?
That was called out as a potential problem with that cap because quota needs to be defined or needs to be something that is checked at admission time. That's the only thing that Kubernetes supports out of the box. So basically, the extended resources cap says that resources must be checked against quota for extended resources if they are defined in the pod spec. And in addition, also the resource DRA quota must be checked. And that may that basically means that an admin needs to define quota for both ways of accessing a DRA device through the class mechanism in a resource claim via a request and through the extended resource mechanism. I think it doesn't do double accounting, but yeah, this is something that was called out in the cap. I don't remember how much it goes into details answering your question, but there were some thoughts on that at least.
Okay, I see. So I'm interested in that question from a queue quota management perspective because we are almost at the state of getting that design approved. But with queue, it would likely be that we don't have an admission plugin that can look at it, but uh, more in like the implementation there will look at the pod template spec in the workload APIs. So I'm assuming that pod template spec in that API will only give the extended resource kind of configuration, and the same problem of double accounting would not apply in that case. Um,
Yeah, so for queue, if you see an extended resource, I think you can just treat it as an extended resource. No special DRA support needed. What the user asks for is an extended resource. And it's counted like a fixed number of extended resource A, B, C. And if you have a quota for that, that's fine, that applies.
Got it. Perfect.
Yeah.
Thank you.
Which ironically might be the way to support DRA. Well, it would be a limited amount, limited support, but current queue might already work with DRA as long as users are only using that new extended resource request API for DRA.
Yes.
That could just work out of a box.
Yes. I think the challenging part is when you have both simple devices as well as complicated devices. how can an admin account for quota on both device plugin style devices as well as DRA devices. So I think there will be like user experience question, but fundamentally, what I'm hearing is this cap doesn't change the calculation part of it. So I think I should be okay. Thank you.
Okay. Well, you're next anyway. Your topic is next with the scalability job.
Yes, I think a couple of folks from this call were interested. So I'm going to put the PR for that here in the chat. But yeah, the quick update is that the perf and scale tests currently did not have the ability to declare a dependency for the test. So as part of this work, a dependency type in the perf scale test was introduced so that the test YAML first has a dependency that you declare in the test, and then you run the test, and at the end of the test, this dependency will be removed as the last step after all the workload in the test is removed. With that dependency, an initial version of perf scale test with the example DRA driver was merged. This creates 100. This was merged against the 100 node test. So we have 800 fake devices, test devices, out of which 90%, so 720 devices are failed first in phase one. Then remaining 80 are churned. So the 80 additional devices will have 10 pods at a time, like 80 pods, but 10 each. So 800 pods like that created. And this test is then measuring the numbers between the phase one and phase two separately, and then reporting it at the end of it. So I just wanted to give an overview of what the test is doing right now. Unfortunately, I don't have the numbers as of now because there was a bug in the way the scheduler numbers were being collected. So we are iterating on that job to fix it. But hopefully by the next call, we'll have both the pod creation to running latency as well as the scheduler evaluation times latency as the numbers to report here. I want to take a pause here if there are questions.
No, but sounds excellent to me. Thanks for doing this. As you know, it is a GA criteria that we do these kind of tests. So I'm glad to have someone help with that.
Yeah, sure. I do think there are a couple more enhancements to the existing test job that I would like to get to before calling this issue complete. Those are first, apart from the scheduler results, we don't have any metrics as of now to say how long it took for a resource claim to be allocated.
Yeah. It would be interesting to find if you find that we should add a metric. We could add that as part of this development cycle, even if it's not in the cap yet. There is a gentleman's agreement with SIG instrumentation that metrics defined in a cap can remain at a lower stability level than the feature itself. There is kind of the goal to have a GA feature only or come with beta metrics, and then the metrics should get promoted shortly after, or should in the next release or sometime soon at least get promoted to. But this is a relatively new guideline and it's not strictly enforced. So I think we can still add new metrics and call them part of core DRA and promote them as needed.
Yeah, that's great. So I think I did some initial brainstorming on what would be the right place to do it. So there are three options that are available. So the two for metrics is either we put it as part of the plugin library, which every plugin author will extend to implement their driver.
నేను తిను ఫస్ట్ అన్నం తిను
You are unmuted.
ఆకలి లేకపోతే తిను ఏదన్నా తింటే వామిటింగ్ అవుతే చూద్దాం అప్పుడు
I think we can mute.
Yeah, I'm looking for the button. Yeah, I found it. Yeah. Okay. Yeah, let's keep that in mind. I'm a bit time constrained, even though I do have time now. I don't have until the end of the next full hour. So if we can just move a little bit faster and go through the agenda for today, that would be good. Otherwise, I need to drop out earlier, and I don't know what that means for the meeting. So yeah, let's keep that in mind. Let's keep iterating on your observations, the gaps that you are seeing, and bring it up at the next meeting again.
Yeah,
Okay.
I'll sync up with you offline on this. I
Yeah.
think there's one more enhancement that I was looking forward to for this. Just want to call it out here. This one will be slightly more challenging, and this is to get some kind of alignment of attributes going. So we would have to introduce a new device with a common attribute and have the alignment tested because that's part of the structured parameters.
Yeah.
Going GA. Yeah, that is a little bit challenging. I think I'll take a stab at it sometime this week and share ideas in the next cycle.
Yeah, or just bring it up on Slack. I think that's always a good step, a good way to make progress while we are not having a meeting.
Yeah.
Yeah. Okay. Next topic. I think that's about resource slices and what devices it should or not contain. I'm not sure if I can open the link in this browser. I might not be logged into Slack here. No, I'm not. Yeah, I can try to answer that question again. So conceptually, a driver publishes everything that it has in the resource slice, and it should ideally never remove devices. Because if a driver removes devices, there is a race condition between the driver removing the device and the scheduler potentially allocating the device. There is something in the CAP that warns about that. I thought we might have to publish it a bit more, say, for example, in our helper package. If it's not there yet, we can add documentation. Antonio, you have your hands up.
Yeah, I want to talk about this because you know that we came to DRA from networking, right? We had these other issues and people were trying to do a different thing and we find common goals and problems and one of the use cases that I'm driving in networking is that the resources are dynamic, right? It's not that you have an interface, a physical interface. You may have something that provides this physical interface, but it's the driver who generates that on the fly. So I agree with you. You should not start moving or reshuffling the resource slice. But the use case that I'm driving is once the resource is allocated, it is no longer available because you don't know if this same resource is going to return back to the slice. That's why I'm trying to
yeah
explain the other day.
Yeah. So if you have published something and you don't know whether it comes back, you can go through let's call it deprecation cycle. You can remove it from the slice. Your driver has to be prepared for losing that race and getting a pod scheduled with a device that no longer exists. So if a driver,
Patrick, 1 second. Let's stop you here because I want to see if we are talking about the same. So this is once the driver allocates the interface. So the interface or whatever is the device. Let's put it. The device is allocated. That is when the driver removes it. So it cannot be a race, right? Because it's already allocated.
So I'm looking at it from a perspective of what's in the resource slice.
Okay, give me that perspective.
Yeah, because that's what Kubernetes sees and works with. So as soon as the driver publishes a device in the resource slice, the scheduler may allocate it.
So Patrick,
yeah.
Sorry, I just want to add something over there. So in this case, what Antonio is saying is that there is, yes, the thing in the scheduler just watches for resource slices and it knows through resource slices which devices are available, but it also accounts for the fact whether the device was allocated in some resource claim or not, right?
Yes.
So I think in this specific situation, yes, it's the case that we are removing a device only after it's been allocated to the resource claim. So I'm wondering whether there's
there's still a race. There's still a race.
This is still okay. Can you please elaborate on that? This is super interesting to me.
I think I did on Slack. Let me try to figure out whether I can get it straight again. So your driver is removing from the resource slice when it sees a resource claim that has the device as allocated. Is that correct?
No. It removes from the once the pod has effectively allocated the interface. It's consumed by the pod.
What does allocated interface mean? Is it the node prepare resources for a pod has succeeded?
Yes.
Okay.
So I think the answer to your question was yes, right? That it happens after the pod has been allocated the resource claim and after the pod actually assigns that network interface to that.
Okay. So in that case,
consumed.
Yeah. Actuated is, I think, the term that we are using in the KEP or in DRA. So we allocate in the scheduler, which means we update the resource claim status with the allocation result. And then the kubelet actuates that state change on the node by calling node prepare resources with the DRA driver. And that means at that point, your driver knows that there is a pod or more or several pods running on the node currently using the resource claim. I think in that case, it may actually be safe kind of to remove the device from the resource slice. There is still a potential race, but I think it's highly unlikely. So what could happen is the following. Your driver removes the device from resource slice, publishes that. Then very quickly, the pod terminates. The node unprepare resource call succeeds. The pod status update triggers deallocation of the claim, and all of that completes before the scheduler actually processes the resource slice update. In that case, what the scheduler sees is the old resource slice, which still has the device that, as far as the scheduler knows, is not in use right now, and it could use that device for another pod, even though your driver removed the device. So there is still a race. It's just very unlikely because deallocating a resource claim, stopping a pod is slow. Advertising that the pod has terminated is slow. Deallocating yet another step through the resource claim controller, a status update to the scheduler. So this chain of events, it's much longer than what happens if your driver updates the resource slice. I'm just putting out this as a theoretic race that exists. In practice, you are probably never going to see it. So in this particular case, it's okay, but it's only okay, or it's less likely to have a problem because you are very careful about only doing it when there is a pod currently consuming the resource claim on the node, because that implies that this unfortunate event of reusing the removed device is so unlikely because there are these additional steps that need to happen before the scheduler would do that again.
Patrick, related to this topic, I think that when you started, you have more about fungible resources with these IP cameras and all this stuff. So how are these people handling this? Because the problem here is
we do have different CAPs that are trying to model more complex devices, like consumable capacity is one. Partitionable devices is another. Both are examples where we enable the scheduler to determine which devices and which resources in a device, in the case of consumable capacity, is still available without having to consult a driver or without having to wait from a reaction from someone. So it's all local to the scheduler, and it always makes the right decision according to the model that we have for the devices.
And I need to model for networking fungible and non-existing device. I saw all these CAP are based on there is hardware in the node. And right now our use case is very simple. It's interfaces that, I mean, it's very static, it's very simple. But now we may move to more complex protocols like MPLS, SRv6, things that are generated on the fly and depend on external infrastructure, right? That's the one that is going to provide, oh, now you have this here, or you now have this in the other place. And that's the...
Yeah. Binding conditions might potentially help you there.
Which is, this is another CAP? Let me write it down.
This is the other CAP that also aims, it's this one here, 5007, that aims for alpha in this cycle. What it does is it allows a driver to publish devices with a condition. We're basically saying, scheduler, I need to acknowledge that it's okay to schedule the pod. So there is an intermediate phase where the scheduler has made a decision which node to use and which devices to use, but the pod hasn't been scheduled yet. At that point, ideally, the device actually is still available and it can be used. And then the driver, DRA driver, just acknowledges that by setting a condition in the resource claim status that it's okay to finish the scheduling. That's
it's like a handshake, right?
Yeah, it's like a handshake. So the scheduler keeps the pod pending. It waits for the status update and only proceeds with binding the pod to the node if it gets the acknowledgement. And there is also a failure path when, in the unlikely, hopefully unlikely case that the device had to be removed in the meantime, the driver could say, this device can't be used, try something else. And if it has, in the meantime, actually done a resource slice update, that's perfectly fine. The scheduler has more information, better information in the next pod scheduling cycle, and it can pick something else. So we don't end up with a pod that is stuck on a node because it has been scheduled and it can't run.
Good. Thank you. Thank you for all. This is very helpful.
Yeah. Okay. Next topic. Yeah. Constraints with cell. So I mentioned initially that this was one of the CAPs that did not get merged because of some, well, late concerns. and I must add that there's also there was a crunch with reviewers again this cycle. We have probably enough on our plate already review this cycle, so that as discussed, I think 2 weeks ago, we had to prioritize, and anything that was recently submitted just basically came at the end after all the things that had been pending for review and had been discussed in more detail before. And constraints with Cell, I know that it was discussed on Slack before, but the cap itself came fairly late, so there wasn't enough time to really do an in-depth review. And yeah, that's the only reason I think why it didn't get merged. Otherwise, it's probably fine. Gita, I think we discussed that also on Slack. I think we just need to address the concerns that David Eads had about complexity, combinatorial explosion of combination of devices that need to be checked. And I think the way to do that is to outline for which kind of setup, which devices this feature is intended. The problem will be then that if we enable feature, users might try to do some, might try to do something we didn't anticipate. And that can cause the filter phase to run for a long time. What we are doing in Core DRA to deal with that is to add a filter timeout. That is in the core or structured parameters cap update for this release. This filter timeout is new. It will be added in this cycle. So it's kind of a bit edge case that we are still making changes for Core DRA and at the same time as we are promoting it to GA. But there will be a separate feature gate for this additional filter check. So if it's causing problems for people who have been happy with the beta, there is a feature gate to turn off the filter timeout. And it's also configurable to be 0. So 2 ways to turn it off in the scheduler configuration and via a feature gate. And I think that needs to be the answer in all caps that run into this question. How complex can the calculation become? You need to make some estimates about what is the expected number of devices, what is the numbers of devices that you expect to have available to be checked, and then do a back of the envelope calculation of, well, what kind of performance or complexity you are expecting for your feature. And if for the expected usage it's not too costly, I think it's fine to add a feature. I think that needs to be the answer in this case too.
Okay, so we just need to basically outline a plan for the complexity to limit the exposure, and would that be enough for alpha?
I think it would be.
Okay.
Yeah.
So-
If the math doesn't turn out to be 100 billion operations, then it should be fine, or 100 billion cell expression computations, because that will take too long.
Yeah.
It's not even the time for a single cell expression evaluation. That's small. It's the combinatorial explosion that kills it. And we've seen that with other cases, even with Core DRA, where some seemingly simple operation that just checks for a large number of devices, large number of requested devices, and there is no solution. This takes seconds, or several seconds, perhaps even minutes to compute, just to find out that there is no solution.
Mhm.
That's why we are adding the timeout, because we basically don't find in any reasonable amount of time a solution, and we just give up on a node.
Okay, makes sense. Thanks.
In terms of next steps, I think we should focus on the cap update first. And that's simply prioritizing things that reviewers need to spend time on. If someone has time from your reviewers to look at the implementation PR, this cycle, even though it's not going to merge, that's fine, of course, but people probably will have to prioritize the other things first. I can't promise anything myself either at this point. It depends a lot on what's coming in and what I need to what I need to finish myself.
Sounds good. Yeah, we'll focus on updating the KEP first and then the implementation PR after.
Okay, last topic for today, I hope, because I need to drop in 10 minutes roughly, is about cluster autoscaler. I believe the cluster autoscaler, well, I know that the cluster autoscaler folks are aware that we are promoting to GA. We explicitly asked in the GA PR for the KEP promotion, and they acknowledge that we are ready to move ahead with the core feature. I don't know what kind of other work they are planning to do. Not sure. I don't think we have. We don't think we have anyone on the call. So Cuba
I can
would.
speak, Patrick.
Okay,
I know Kuba's
you
not here,
know
but
that.
I'm an autoscaling tech lead. So I would love to just hear about the person who put that agenda item in the meeting. What concerns do you have?
So, hi, Jack. Yes, I put it there. So, my no particular concern, but just wondering whether the base support for DRA is available in Cluster Autoscaler or not. Basically, if I have a workload which uses DRA-based resource allocation, will Cluster Autoscaler work with it or not? Just basic autoscaling, like scaling up one node at a time. And
Yeah,
if it will work, then does a specific DRA driver need to do something specific to integrate with the Cluster Autoscaler?
Yeah, those are great questions. So I would say the answer is basic structured parameters, DRA behavior, and basic cluster autoscaling works in 132, and 133 is in the process of being cut right now. Because of, you mentioned the DRA driver, there are some other operational realities that folks have to deal with, but in particular, that lag that exists when a new node comes online, depending on how the DRA driver installation is operationalized. If it's a daemon set or something like that, sometimes it requires an additional reboot to apply configuration. So for cluster autoscaler administrators, you want to sort of develop a DRA tuned configuration to make sure it works with your particular DRA setup. But the basic functionality is there. And I think it's worth calling out that in terms of GA promotion in core Kubernetes of DRA, cluster autoscaler sort of by design trails behind Kubernetes. So cluster autoscaler can't like block promotion of GA because that would essentially amount to hunting it back another release. The process for releasing cluster autoscaler is to, at some point during the Kubernetes release cycle, take in the sort of like alpha, some commit that represents what the current release is likely to look like. And then at the very end of the release cycle, you pull in the actual commit, and then you do some validation, and then you cut a release. But that means that cluster autoscaler trails Kubernetes. So all that's to say, in the cluster autoscaler community, we feel confident that the basic set of functionality is there. So from a cluster autoscaler standpoint, we're thumbs up for DRA or DRA GA.
Got it. Thanks, Frank, Jack. So regarding the second question, is there something specific that a DRA driver has to do in order to integrate with this basic functionality, or does everything come out of the box?
It's mostly the second one, but optimizing that the way that a DRA driver attaches to a new node that comes online, because cluster autoscaler is responsible for replicating out additional infrastructure. It's not responsible for carrying out the DRA driver installation. So the DRA driver installation could be a part of the provisioner. The node, the VM or the machine could come online with the DRA drivers pre-installed. That's one option. Probably a more typical option is that the machine comes online with the correct node selection criteria, which then sends a new daemon set pod with the DRA drivers onto that node, which then installs. But that second, more typical scenario is going to mean that DRA driver installed nodes may take longer to come online.
Yeah, I think that's the node readiness. And when the autoscaler knows that the node really has been brought up completely, I remember that there were hacks for device plugins to compensate for that delay. I don't know how
Yeah, the node
concrete
readiness
that is.
will definitely sort of standardize how we do this. So
Yeah.
that will have to go into cluster autoscaler as well once that kept
Yeah.
lands.
It might actually be interesting to have some documentation in the cluster autoscaler for DRA related aspects. Because if there is anything that needs to be tweaked, it would be good to know what those tweaks potentially could look like. But yeah, to second what was said before, DRA drivers ideally shouldn't need to do anything special. They publish resource slices. So if the cluster autoscaler works by cloning an existing node in a node pool, I think what it currently does, it just clones the resource slices and assumes that all of them will be also available in the same shape and form and number in the fictional node that it simulates. And in that case, it doesn't even need any particular configuration in the cluster. It will just use what's available in a running cluster as input. I believe.
Yeah, that's right. The part that the asterisk is, and this is where documentation will be helpful, is cluster autoscaler does set a TTL in terms of waiting for the terminal outcome. And the terminal outcome is the pods actually getting scheduled and going into a running state.
Yeah.
So I don't want to make this super complicated, but let's imagine we've got not just DRA drivers, but also GPU operator with MIG configuration. You can delay your node readiness by like 10 minutes in certain situations. And so in an environment like that, cluster autoscaler administrators need to probably increase the TTL tolerance of the sort of wait for scale out configuration, because that's part of the overall flow. Is as Patrick said, picking a candidate node is relatively easy. You just simply replicate the resource slice. You assume they're all going to be the same, so you can confidently project what kind of new nodes you need. But cluster autoscaler is also waiting the entire time to make sure that its recipe actually worked in practice, and that is waiting for the pod to go pending. So if you're a cluster administrator who runs a super lean configuration where you expect nodes to come online really quickly, and if they don't, you want to just restart the entire process, you might need to up your tolerance with an environment like GPU operator plus DRA kind of thing. Go ahead, Gaurav.
Thanks a lot for the feedback, first of all. I totally agree. I think some of this could definitely use some help with some appropriate documentation. So does this mean, if I'm understanding this correctly, that cluster autoscaler right now is consuming resource slices, and based on resource slices, it is determining which nodes to scale up?
In 132, that's right, yeah.
Okay,
and there's a feature flag in cluster autoscaler, so you have to enable that.
Okay. So yeah. I think this ties back to the question number 3 in today's discussion that we were having some thoughts about, which is that whether resource slices are supposed to be static in nature or not, because if you remove the devices from resource slices dynamically, then cluster autoscaler has no way of figuring out what the actual state of that node is, right? Am I correct in understanding this?
Yeah, I think your understanding is correct.
I want to say we're at time. Let's talk about that in the cluster autoscaler meeting. Yeah, that's a really great topic.
Okay.
Anybody submitting any KubeCon talks? That's a good one.
Okay, well, thanks for your understanding, but I need to drop off, and thanks for a reminder. I now need to rush, get my bike ready, and go somewhere. So thanks for the lively discussion. It was good to have you all there again, and see you in 2 weeks, or perhaps next week on Monday morning. You're all welcome to also join that one. Goodbye.
Thank you. Bye-bye.